transformation of functions today. Transformation of function. So the first transformation we're going to discuss is going to be deflection on x-axis. Here's a curve. If I reflect that curve, I'm going to call it fx. If I reflect the curve, then it will look like this, roughly. Internet connection is unstable. Stop video. Okay, can you hear me? Hello?
Yep.
All right. So if I reflect this, it becomes a new function which can be called gx, right? This is what the reflection would look like. But this gx would be equals to minus fx. Because see, every value of y now becomes negative. Like for if this was मैंने अच्छा नहीं reflect किया, hold on, the reflection will look like this. It will look like this. All right. So that value, let's say this was 8. Now it's minus 8. This here, let's say, was 2. Now that's minus 2. So every value of y now has a negative sign instead of the positive sign. So reflection on the x-axis is minus fx. Understood?
Yep.
So if fx is, let's say, 2x square plus 5x plus 2, for example, then gx would be negative fx, which will be multiply fx with minus 1. So minus 2x square minus 5x minus 2. All the signs flip.
Okay.
Okay, so that is reflection on the x-axis. Okay, I'm going to clear the screen and make a fresh x and y axis. You do that too. Now we're going to discuss reflection on the y-axis. Okay, so here's another graph. Let's say it looks like this. This is fx. If we reflect it on the y-axis, it will look like this. I'm calling it gx. Now, gx would be f minus x. Because notice, now the values of y are the same. For example, value of y for this one is 8. Then the value of y for this one is also 8. Value of y is not changing. But if x here was 3, now x here is minus 3. So the value of x is being multiplied with minus 1. So fx, if that's the original function, then gx is f minus x, which is a reflection on the x-axis. That means if fx is, let's say, x cubed plus 3x squared plus 2x minus 8, then f minus x would be gx. And you're going to replace x with minus x throughout.
Wait, so then the first one was that reflection on the y-axis?
No, the first one was reflection on the x-axis. This one is reflection on the y-axis.
Oh, okay.
The first one was reflection on the x-axis, where if this was fx, then this was minus I reflect like this would be minus fx, because the values of y are changing their sign. But when you
Right.
reflect on the y-axis, the values of x change its sign. Then it's going to be 2 times minus x minus 8, which is minus x cubed plus 3x squared minus 2x minus 8.
Okay.
Now we're going to discuss let's discuss translation. So let's say translation by 0k. That means that if this is fx, then gx goes certain units up or down. This would be gx. I'm still getting my internet connection is unstable warning. Can you hear me?
Yes, I can.
Okay, good. All right. So if let's say this is 2 here, then gx is actually fx plus 2, because it has gone 2 units up. And if let's say gx comes down like this, and let's say this is minus 3, then I'd say I'm calling it something else. Let's call it kx. This would be fx is brought 3 units down, so fx minus 3. Give me a
Okay.
So if fx is let's say 3x squared, 3x squared minus 2x plus 1, then if it becomes fx plus 2, which was gx, fx goes 2 units up, then just add 2 to your fx. It will be 3x squared minus 2x plus 1 plus 2. So this would be 3 now. And if it is kx, in which fx goes 3 units down, so just subtract 3 from fx. So that's 2x squared minus 2x minus 2.
It's lagging.
Okay, hold on. Let me just ask everybody to turn off anything they might be watching on the internet. Can you hear me?
Yes.
All right. So have you understood this? That if fx goes 2 units up, it becomes fx plus 2. And if it goes 3 units down,
Yep.
it is fx minus 3. All right. Okay. And how do you explain this? Gx, what is Gx? You're going to write it is translation by, it's called translation. Translation by, it did not go right or left, so you write 0 and 2 here. Translation by 0, 2, that means 2 up. And what about kx? This is translation by 0 minus 3. Understood?
Yep.
Let's make more space now for translation along the x-axis. So translation by K0. Okay. So now what if this graph moves certain units to the left, let's say, certain units to the right. It goes 8 units to the right. So this, if this is fx,
H0?
yes, if this is fx and this is gx, then you're going to say that gx is, in terms of fx, this will be f x. You're going to write -8 here. You use the opposite sign. That's because x is 8 here, and when you move x to the other side, it becomes -8. So you write f x -8. That means that your graph has shifted 8 units to the right. And in other words, all right, that I think my kids might be playing Nintendo or something upstairs.
Oh.
Okay. So did you catch that? Where I said that gx is equals to fx -8.
No.
Okay. So when you're moving the graph 8 units to the right, you have to write fx -8. Although it moved towards +8, but you have to write -8. That is because when you write x is equals to 8, and when you send x to the other 8 to the other side, it becomes x -8. So this is where it comes from. So that's why when you're moving it right, you must write negative with that. Right? And this is
If we're moving it
translation
left?
by, sorry,
If we're moving it by left?
I'll tell you that. Translation by 8, 8 right and 0 up. It's 8 and 0. Here you write 8. Okay. If it goes certain units towards the left, let's say it goes 12 units towards the left, and let's call it kx. So then kx is f x plus 12, because x is -12, and when you send this to the other side, it becomes x plus 12. And this is translation by, it goes 12 left and 0 up or down. So -12, 0. That means if fx is, let's say, x squared plus 3x minus 2, then gx will be fx minus 8, which is going to be x minus 8 whole square plus 3 times x minus 8 minus 2. I'm not simplifying it, but you may need to in the worksheet. Similarly, kx would be, since it's fx plus 12, so it's going to be x plus 12 whole square plus 3x plus 12 minus 2. Understood?
Yep.
Okay. Now we're going to discuss translation by JK. That means it moves in both the direction, x direction as well and y direction as well. Okay. Let's say that was fx, and fx moves. This is the origin. Okay, fx moves 4 right and let's say 3 up. So it's now here, calling it gx. So now you're going to write gx equals f bracket x minus 4 because it has moved 4 units to the right. And then outside you write plus 3 because it has moved 3 units up.
Okay.
So similarly, if it moves left and certain units down, let's say it moves to minus 7, and here it is minus 5. So that would be kx, which is the function fx has moved 7 places to the left. So you write x plus 7, and then it is going 5 down, so minus 5. And in words, this is translation by 4 right, 3 up, and this is translation by 7 left, 5 up, 5 down, sorry. 7 left, 5. Now let's say if fx were given to you and it was, let's say, x squared plus x minus 1, then gx would be, x is changing into x minus 4. So x minus 4 whole square plus x minus 4 minus 1, and then add 3 to it as well. And then simplify it.
Okay.
And can you tell me what kx will be equals to? Kx is this, fx plus 7 minus 5. So what changes do you make to fx?
It's gonna be x minus 7 whole square.
Oh no, it's going to be x plus 7 whole square. X will be
Plus,
replaced
yes,
x plus 7 whole square, then what?
plus x plus 7
Then
minus 1 and then minus 5.
that is correct. And then you simplify it. So that was all about translation. Now let's discuss stretch. Okay. So we're going to discuss vertical stretch first, or stretch parallel to y-axis. Okay. So here's a graph. Let's say it's like this. This is 5. That's 8. That's 2. And that's, let's say, 4. And this is fx. So if you have to stretch it, stretch fx parallel to y-axis with scale factor or with stretch factor, let's say 3. 3 is the scale factor, and you're stretching it parallel to the y-axis. if it is being stretched parallel to the y-axis, then this value of y here at 5 gets multiplied with 3, which gives us 6. So now at 5, you'll get 6. Let's say 6 is here. So at 5, you'll now have 6. And here, when x was 8, y was 4. So now you multiply 4 with 3. That is 12. So it goes up. Let's say यहाँ पे कहीं है 12. So at 8, now the y coordinate will be 12. And this is what the stretched graph looks like. This graph has stretched 3 units. This graph is stretched parallel to the y-axis with scale factor 3, calling that gx. So
Okay.
gx is actually 3 times fx, which means it's stretched parallel to y-axis with scale factor 3. In fact, I've already written that over here. Okay. I'm going to end this lesson and you're sending me a new link.
Okay.
Now we're going to discuss stretch. Acha, no, we're not done discussing this stretch. All right, so that means that if fx is, let's say, x square minus 3x plus 2, then gx will be 3 times of fx, which is just going to be 3x squared minus 3x, minus 9x plus 6. All right.
Yep.
Now let's discuss stretch parallel to the x-axis. So let's say we have a curve like this, and we have, let's say, 2 here. Let me make it bigger. And let's say that this is 1 and that's 10, the top. Okay. So calling it fx. Now, if we are stretching it parallel to the x-axis, stretch parallel to x-axis with scale factor 2. Now what happens is that the value of y stays the same, but the value of x changes. And how are you going to represent it in the form of gx? Gx will now be, you write f half of x. And where did this half come from? You have to take reciprocal of the scale factor. You have to take reciprocal of this. So gx equals half of x. Okay. I just need a quick second. I'll be right back.
Okay.
Okay. Now, what does this 2 changes into? It doubles because the scale factor is 2 and it's now 4. So we'll have this here. And what happens to the 8? It doubles and now it lands at 16. So now you'll have the same height at 16. Let's say 16 is here. And then is this graph was peaking somewhere in between. Let's say it was peaking at this is going to be 5, the mid value of 2 and 8. The average of 2 and 8 is 5. So now it will peak at 10. So that peak that was earlier at 5, now it will be seen at 10. At 10. So this is what the stretched graph look like. It has now stretched parallel to the x-axis. So all the existing points on the x-axis got multiplied with 2, but nothing happened to the values on the y-axis. Y is still 1 for the extreme two values, and y is still 10 for the mid value of x. But the graph has clearly stretched parallel to the x-axis. And remember, whenever there's a stretch parallel to the x-axis, when you're representing it in the form of gx, you will take the reciprocal of the scale factor. So you write 1 by 3x. Similarly, let's say if the stretch factor was 5, then you would write gx equals 1 by f 1 by 5x. What if the stretch factor is half?
It's gonna be f2x.
Yes. Stretch parallel to x-axis with stretch factor or scale factor half. So now I'm calling that function kx. Kx will be f, take reciprocal of half, 2 and x. And this will actually be a shrink because you're multiplying the values of x with half. The function will actually shrink, but we call it stretch nonetheless. You don't write shrink in the exam or the test. It's stretch. But since the scale factor is half, so that means obviously it's going to become smaller than the original value. Okay, so 2 gets multiplied with half, the original fx function. This function, the 2 gets multiplied with half, so it lands at 1. Here, okay. And then 8 gets multiplied with half, it lands at 4. And in between these two, we have 2.5, which is half of 5. Where the function was earlier peaking. So now the function will peak at half of 5, and this is what it will look like, which is the values of y are still the same. Extreme values 1 pe hai. The mid value peaks at 10. They're still 1 and 10. But the values of x have been now multiplied with half. So that is stretch parallel to the x-axis with scale factor half. I think I've discussed all the stretches with you. So now let's just quickly take a look at the example. So if, let's say fx is originally x squared minus 3x minus 5, then what will be gx? Gx is the stretch parallel to the x-axis with scale factor 2. So now what you do, you change the values of x to half x. So all values of x change into half x.
Okay.
And for kx, kx was stretched parallel to the x-axis but with scale factor half. So that became f2x. So that would be 2x whole square minus 3 times 2x minus 5. This is this, and that's that. All right, that's all for today. I'll inshallah see you tomorrow.
Yep. Allah Hafiz.
Yes.